Okay, let's get going. Assignment number 14, you were given 5 problems on Friday. It said in my letter this morning that I'll solve all 5, see how long it takes, and again, I got to watch blocking the board, or the whiteboard all the time. Okay, and the first problem, it's like an hourglass, right? Looks like one to me. And we don't need them to be, but the cones are going to be congruent. You were told that. So the idea is to calculate the empty area here. We'll be doing more problems like that as we go along. And so the paradigm, or the way we look at this, is the cylinder less 2 times the cones. And you should think like this when you do the math. It should be easy for you to do that. All right? So that's the setup. And once you set it up, you should be in pretty good shape. The data we're given is h equals 6 and r equals 6. We're always watching between r and d, okay? And there we set it up, and it's pi 6 squared times 6, the formula for your cylinder. Minus 2, of course the 2 stays, we're just going to double the data, and we get 1/3 pi 6 squared times 3, and I immediately don't waste any time to take care of that to make the math easier. So then when I put everything together, 6 cubed is 216, so that's 216 pi, and I'm subtracting whatever this comes out to be. So let's see, we have 36 pi, that's all that's left when we got rid of that, times 2, so that's 72 pi. And you can use a calculator if you don't want to be slowed up, but the answer turns out to be 144 pi. You should have been able to come up with that. That's not a difficult problem. Quickly moving on to number 2. I have a sphere, and that is the ratio with with some sort of cone. So I'm just again going to put in the data here. Remember, the sphere has no height, okay? And here it's diameter, so you've got to be careful there. So that means r is 3. By now that's been explained to you. And h equals 4. Just data, just practice, so you can get used to doing these things. So the sphere is 4/3 pi. The radius is multiplied cubed. And on the bottom here, we have our 1/3 pi. And then we multiply that times 3 times 3 times 4, always following the data. Now, there are lots of ways to do this problem. I mean, really, you should practice these things. Let's just cancel the 3's, and then we can cancel the 5's, and then we can cancel the 4's. So we're in great shape already as we move along here. What's left? 4 times 4 times 4. And on the bottom, what do we have? 3 times 3. Well, it's been explained so many times before, these numbers are coprime. They can't be reduced. So 4 cubed is 64. You're supposed to know that. 3 squared is 9. You're supposed to know that. So the ratio's around 6:1. Sphere to the cone. Okay? Because I'm thinking 9 goes into 63. 7:1, excuse me. 9 goes into 63 7 times. So it's roughly 7:1 ratio. All right? So that's what you should have come up with. This is the correct answer, but this is just nothing like a scientific or common sense answer for number 2. So I move on to number 3. What's it say there? 4 minutes. We're doing good. And I set up the problem. Hopefully this math is becoming easy for you. Okay? And it says calculate the difference between 2 regular cans of soup. Okay? Given the data, r equals 6, h equals 9, and maybe a super family size. And you were asked to do that as a problem last week. It was solved, And this is just practice for you to see if you can do it. All right? So here we go again. And again, we write in the data here. We got h equals 9. And here, h equals 6. And the radius here is 12. So question is, are 2 cans bigger than the supersized can? If so, by how much? If not, by how much less? Simple question. So I have 2 cans. So there's 2 times pi times 6 squared times 9. Okay, so that's going to be both of them. See, the 2 takes care of that. And when I work out the math there, which you can do on a calculator if you choose, you're going to come up with 648 pi. Okay, so all that's left for me to do now is to figure out what the supersize is doing. Well, we'll write the super, so this is the 2 cans, the regular, and I make a little picture over here so I'm aware of what I'm doing. The supersized can turns out to be pi 12 squared times 6. When I do the math there and work it all out, I get 864 pi. So what's the answer? The answer is the difference between these two. So it's just simply 864 pi minus 648 pi, the 2 cans. And since pi is a like term, when you do the math, I came up with 216 pi, which would be the correct answer. The difference in volume between the 2 objects of this and 1 object of that. Just a math exercise to see if you could put everything together. I presume you could do that. All right. Anybody who's having trouble, you email me, and I'll make adjustments to the course to make it either easier or harder, depending on what your level of comprehension is. Okay, when I assigned the ice cream cone, this is number 4 now, the other day, we remember that this is a half sphere. They like this problem, that's why I'm giving it to you. Okay? And this is number 4, and we only need a radius here, so I made the number really small. The radius equals 2, and the height of this cone is h equals 3. We're still talking units, of course. And the idea is, what's the volume of this compound figure going to be? So we're still giving you chances to practice compound figures. So it's the half radius plus the cone, as I've said so many times before. And it works because they share the same radius. As I said before, it's a compound figure. So there we go. We have all the data we need, just 2 lousy numbers, and we're off to the races. The half sphere is 2 pi, 2 cubed. Notice I'm trying to keep the numbers easy. We don't want to turn this into exercises we're not interested in doing. Plus, there we go. Oh, it's 2 cubed. We have that there. I'm sorry. Plus 1/3 pi 2 squared times 3. So there we go again. I'm going to leave the 3 here. Again, I'm looking at coprimeness. I only have 2's on the top. I can't get rid of the 3, so I'll need the 3 here. So I'll just do all the math here, and 2 to the 4th is 16 pi over 3. And then again, this is 12 pi over 3. And I just explained to you there's no reason to turn this into 4 because I have to put them together anyway. And so when I add them together, I get 28 pi over 3. And then I divide 3 into 28, and I end up getting 3 into 28. Probably a calculator is not a good idea here. And you get 9, remainder 1. So the proper answer is 9. Is it going up here? Yes, it is. 9 and 1/3 pi. Okay? And there we go. Adding these guys together using the data that we were given. And on a math test, you'd be expected to do this kind of stuff easily. Okay, so now finally we go on to number 5, time. Okay, see if we can sneak this problem in here. I erase quickly. It's getting long, the video. Don't want to make it too long or I wasted my time. So you have the radius of a cone is r equals 6, and you have the height equals 10. And if the radius is doubled and the height decreased by 4 units, find the ratio between the new and the original. So here we go again, same kind of problem. I get the original here, and it turns out that this is going to be the original. We'll just write that like that. And the original is going to be 1/3 pi 6 squared times 10, as the data indicate. Okay? So there's my original. I'm going to leave it like that. There's no purpose evaluating this and getting 120 pi. No one's asking you that. They're asking you to find the ratio between the original and the new. So the new will come up with that number. And when we do the new, trying to be careful here, we have 1/3 pi, and the radius doubled, so that's 12 squared, and the height went down 4 inches, so 10 minus 4 is 6, and there we have it. We have one guy, the original, divided by the new. But however, we asked you to do the new first, so I'll rewrite the problem. I can't resist doing that right away, and I'll get the other side here in a second. So I have pi 12 times 12 times 2, and divided by 1/3 pi 6 times 6 times 10. And we'll get to work right here really quick. The pi's are going to disappear. 3 goes into 6 2 times. That makes the 2's go away. 6 goes into 12 2 times. See what we're doing here, guys? So we keep all our numbers together. Let's rewrite here. I have 2 times 12. Those numbers are still alive. I didn't cancel those yet. And on the bottom, I have got rid of everybody here. Yes, the 2's and everybody. And I have 10 over here. Well, 10 goes into 2 goes into 10 5 times. And it looks like I forgot a 2 over here. There it is. I'm bringing this down over here. And the answer turns out to be a ratio of 24 to 5, or approximately, this would be the correct answer, a 5-to-1 ratio, okay, of the new to the old. So that means by doubling the radius, I made the figure much, much larger than simply lowering the height. So I'm up to almost 13 minutes. I better turn this off now.